So do you even care about privacy? Because I mean, I don't necessarily care about it. My passwords are not the safest because I've never been hacked or lost any data to lack of security. But at some point, I might, and then I would regret it not being safe enough.
Well, I would say that in general, you have to know the domain that you are working with. You need to know that there are things that you need to take care of with extra caution, and there are things that you don't. To me personally, if I were to design solutions for myself, I would go the safer way. Like, because I don't mind it. I have like Keybase on my computer. Like, no one has Keybase on their computer, right? I have my own public key that is available to everyone, and I go on and, for example, go on my GitHub account and say that here, this is my public key. So they know now that if they trust my GitHub, because this is always a problem, like you see a public key on the internet, Roham is saying that this public key is mine. How do you know? How do you know that it's Roham who is saying that this public key is mine? You know? So like even the initial connection might never be the case. It's like if you never see that person in real life and he doesn't hand in the public key to you, like how do you know that this is the person who gave you the public key? Like end-to-end encrypted messaging. Sounds good. But how you know that WhatsApp is not having like a middleman in between? Like you are end-to-end encrypted with this middleman, and that middleman is end-to-end encrypted with like someone else. How do you know that?
Do you think they do?
No, I'm not saying that they do.
Okay.
I'm just saying that like, just to show you like the problems with it. So there is always this problem. Like for example, the way that Signals is trying to solve it is that when you meet your friend, you can, for example, I don't know, like they have like this QR. I'm not using Signal personally. So what I've seen is they have this QR code, and then like you can scan your friend's QR code. Like the way that Telegram does it, probably you've seen when you are maybe in a secret chat or when you are voice calling with someone. Like it shows like 4 emojis. And so you can, for example, confirm that those 4 emojis are the same on both devices. This is like kind of the key you're using in order to communicate. Now, again, all of that said, it is still not like a 100% thing. The thing is, first let me like give some sort of introduction, maybe not only to you, but for everyone who will later listen to this. So, like how private public key works in general. Before private key public key was a thing, before this asymmetric cryptography was a thing, we were using symmetric cryptography. And symmetric cryptography uses like one key specifically. And this makes a lot of sense for a lot of people. For example, like the very simple encryption that like everyone can use is something like a Caesar cipher. So what is a Caesar cipher? A Caesar cipher is, say that you have a text. So it's like, hello, my name is Hossein, etc., etc. And you just like choose a number, usually like from like 0 to 25. And then you just shift cyclically. Is that a word? You do like a cycle shift on each one of those letters. So say if your key is 3, when you see the letter A, you go B, C, D. So instead of A, you put D. The very dumb way of like encrypting something, quote unquote. So of course it's very bad because there are only 26 different possibilities. And like when you do it, like when you just scan it even with your eyes, you can kind of see like what is the message. If you know that this is kind of the encryption that is being used here. The other problem, even if it was hard to guess everything, say that there is like another algorithm that has like many more possibilities. Once you have that key, you can just revert it back, right? Like once you have 3, immediately you can just go 3 back. So these kind of encryptions are called symmetric because there is a symmetry here. You encrypt with the same key, and when you go back, you kind of decrypt with the same key. So the encrypted and decrypted, they kind of use the same algorithm here. But asymmetric cryptography, which is kind of the basis of everything, including the safe web and all of that, that is when you are generating the key for yourself. You're not only getting one key and you're sharing that key. No, you're getting two keys. You get a private key and you get a public key. When you get you can use that private key to, for example, encrypt stuff. But the thing is, you don't have to share it with anyone, as the name suggests. You never share it with anyone. You only share the public key with other people. And the good thing is, if someone wants to encrypt something and send it to you, they can use your public key and say, "Hi, Roham, here is my secret information. Colin, secret information." Get that text file, get your public key, and then encrypt it into a encrypted message. So now it's like 1x04 and whatever. They send this over internet to you. You use your private key to decrypt that. That's kind of the genius of this. So you pass in your public key. They use your public key with their text to encrypt it. You pass it over the internet or whatever, over the phone, however you want to pass it. Since you have private key of Roham, you will be able to decrypt it.
So there are 4 keys involved here.
There are only 2. So there's a public key and a private key.
No, but between the two of us, if we're texting, in total there are 4.
Yeah.
Okay.
So each one of you have a public key and a private key. Private key you never share, and public key, like there can be like 100,000 people in the world who have your public key. The thing that they can do with your public key is to encrypt stuff with it. Okay, that's great. They can encrypt stuff with it that they know that only you and only you can read. Because you have the private key paired with that specific public key.
Okay.
So like I say hello, I have your public key, I turn it into something, someone else says hi, we both send it over the line, you use your private key to decipher that. If someone in the middle of the line intercepts and sees my message, they see 10AX, whatever, right? Like
just random.
It's just like random bits.
And how hard is it to decrypt?
It's pretty difficult. I mean, depending on like what encryption you use, how many bits of like what is your entropy of all of this randomness and all of that. It is obviously very difficult. And every couple of years they say, oh well, we are not going to use this anymore. This is considered to be vulnerable. For example, we found this vulnerability, or our computation power is now at a point that we can kind of decipher this. So they go to the next step. So it's always like this race against the times and the hackers and like whatever. But that's usually the way that the security goes forward. And now all of these things, you are a person with a podcast and like all of that. You on a day-to-day basis, you are using the computer like every single day. You go to all of these websites. All of these websites have like a HTTPS. This stands for Hypertext Transfer Protocol Secure. And the S in it basically says that let's have a secure handshake between we even start to talk to each other, between you and the server. So basically what you do is that you kind of transfer your public keys in a way. So whenever you want to, so if you want to send something, you use the server's public key. Whenever the server wants to send you something, the server uses your public key. And since you have the private key, obviously you can after this exchange, you will be fine. Now, This is kind of a slow algorithm in general, like to encrypt and decrypt every single time. So what you usually do is that in this handshake, you actually pass in a symmetric key from the symmetric cryptography, which is faster. But you pass that in encrypted. So you pass that symmetric key itself encrypted. So when you pass that, then you know that like even if someone intercepts in the middle, they couldn't find the actual symmetric key. They just found some nonsense. Now you can send back and forth between the server the stuff that is encrypted with the symmetric key. So this is faster for you to surf the web and all of that. What I'm getting at with all of this information is that maybe some would argue that these are some of the stuff that should be taught at the school. Some of the schools are teaching this. The society as a whole is not really being like tech savvy enough for all of these things. Now we are bombarded with Bitcoin and all of that. Ask this normal person who is investing in it like heavily, like what is the underlying technology? And they have no clue. And I think this is a problem. This is a big problem because like you should know what you believe in. If this would be anything else, people would be mad about it. Like, oh, why people are like following this like herd